Hello guys, this is Paul McWhorter from TopTechBoy.com, and we are here today with lesson number 17 in our most excellent new and improved Arduino tutorials. I need you to pour yourself a nice big mug of iced coffee. That is strong black coffee poured over ice. No sugar, none needed. Straight black coffee over ice. It is most refreshing if you become a little parched. You're going to need some of this to get through this lesson. What are you also going to need? You're going to need your most excellent eLego Super Starter Kit, the Uno R3 project kit. If you don't have one yet, look in the description at the link, hook a brother up, click on it, get one. This has a boatload of components. It's about $35. It's got the Arduino and the components, and all of this series of lessons is based on this. And if you get one, we're working with the same components. Okay, what are we going to talk about today in lesson number 17? We're going to talk about while loops, okay? The last two lessons have been about for loops. And anything that you can do with a for loop, pretty much you can do it with a while loop. And some people like while loops better, some people like for loops better, and I think probably more people use the for loop just because they're kind of programmed that way. But I find the while loop I like the while loop a little better because anything you can do with a for loop, you can do with a while loop. But the while loop, to me, it works a little bit better when we're kind of working on an Arduino with a project with different things. Because if you think about the for loop, it's sort of centered around counting. So you say things like start at this number and then go to this number and then increment the number this many times. So it's very structured. To where the while loop, it allows a little more flexibility. So you could say something, well, I want you to loop as long as the temperature is less than 50, and then when the temperature is more than 50, I want you to do something. So the while loop, to me, works a little bit more naturally with the project-based nature of the things that we are doing with the Arduino. Okay, let's jump in and get started here. And I need to switch over to a more suitable view for you. How about this one? I kind of like that one. This is a new one for us. I kind of like it. Let me get out of your way here, and let's look at how we would do a while loop. Again, I'll be using some constants, which we normally don't want to do, but it just helps me show you how a while loop works. Okay, so let's come in and let's get us a counter. So I'll say int, and I'll say j, and I'm just going to leave it like that, okay? And then we are going to need our serial monitor, so we are going to say serial.begin, and we are going to set a baud rate at the trusty old 9600. Okay, now here, what we can do is we can create a loop here, and let's just count to 10. So what I could say is while, okay, turns a happy little green, so it recognizes it. And then what is the condition that I want to loop under? While j is less than or equal to 10. So this is just saying open curly starts the clause, and then I hate it when it does this, but you see it automatically put the close curly in. And then this curly ends the for loop. So while j is less than or equal to 10, and let's just say I'll start here with j is equal to 1, because remember, up here we didn't give j a value, so here before we loop we got to give it a value. Remember, in the for loop, that starting point was kind of put inside the parameters of the for loop. Well, here the only parameter for the while loop is, hey man, you keep looping as long as j is less than or equal to 10. And then here we would go serial.println, and what are we going to print? We're going to print j, and then we're going to go like that. Okay, I want you to just think on your own and kind of tell me what this is going to do. It says while j is less than or equal to 10, print j. Do you have in your mind what it's going to do? Okay, I have got to switch the view here for you to see the serial monitor, I do believe. Let me get this nonsense out of the way for you. Okay, so let's download this. Boom, that was a pretty easy program. We did not get any errors. So now let's look at the serial monitor, and what is it going to do? It just prints 1, 1, 1, 1, 1, 1, 1, 1, and it goes on forever. Why? Let's think about it. We set j is equal to 1. We said loop as long as j is less than or equal to 10, and then serial print line j. Did j ever change? J never changed. This program runs forever. It's an infinite loop. It will never stop. So what do we need to do inside of here? Well, we better down at the last step say j is equal to j plus 1. So you see now this is starting to look kind of like the for loop. Remember, the for loop had this starting condition as a parameter, and it had the increment as a parameter, and it was called a for loop. Well, if you just move those parameters before the while loop, and it's the last step of the while loop, and then also here I'm just going to do a serial.println of nothing, like that. So as it goes out of the while loop, it'll print a blank line. So let's look and see what this does. Oh, what did I forgot? You forgot to hold your breath, right? We got to hold our breath when we download the code, and I forgot the semicolon. But the real reason you didn't hold your breath. So let's hold our breath when we compile. Boom! You see it works when we hold our breath. Now let's come up and look at this, and ooh, also, man, you really need to put a delay in here. So we're going to say delay 500. No, you use variables. So we're going to come up here, int delay time equals 500, and then we're going to come down here and put in delay time. Okay, hold your breath. Boom, boom. Okay, so now let's look at this. So what's it going to do? 1, 2, 3, 4, 5, 7, 8, 9, 10. Skip a line 1, 2. This does like our for loop, okay, but it's just a little different format, and that is a while loop. And let me tell you, I really like the while loop better because it's a little bit more in line with a little more flexibility, I think, and a little bit easier for me to think about. And so what I want you to do is, let me get rid of this nonsense, and I'll leave that. Okay, let's come over and let's build a circuit. And what I need you to do is get out your most excellent eLego kit, and then I need to come up with a view that you can see here. Let's try this one. Okay, so what are you going to need? You are going to need your eLego Arduino Uno R3. You're going to need a red LED. If you prefer, you can use the yellow, but do not use the blue. Do not use the green. We save those for special occasions, okay? So you can use the red or the yellow. And there's going to be someone that uses the blue and then leaves a comment, I use the blue anyway. Better be careful. I might ban you from the channel for using a blue LED when there is not a special occasion. Okay, we're going to have the red LED, a current limiting resistor, and we are going to have the potentiometer. You guys, we've been through this several times in the earlier lessons, so I'm going to go fast. If you cannot keep up, then go back and review some of our earlier lessons, like using a breadboard and hooking up an LED. Okay, so this, we're going to put those two pins on the potentiometer. I'm going to start like in column 10, and then as I plug this in, we straddle that center loop. Okay, the left leg, my left, I'm going to put at 5 volts. Okay, so this we're just going to power up at 5 volts, and then the right leg of the potentiometer, man, this pin does not want to go in. The right leg of the potentiometer is going to go to GND. All right, now I want to read the value, this lower center pin, the lower center pin on the potentiometer, I want to read that value, so I'm going to go to A0. So now I'm set up to read off the potentiometer. Now I'm going to go between column 15 and column 20 with my resistor, and then the long leg of the LED goes to the bottom leg of the resistor, And now I need to take that to a pin that I'm going to control, which is going to be pin 7. I'm just kind of making this up as I go along. I am just winging it. And then we need to take the short leg of the LED, and we need to take that to a ground. All right. So now we are set up to read from, the potentiometer and then decide to do something with the LED. Okay, so what are we going to need to do over here at the code? We need to get something that you can see what you need to see, and I wonder what that would be. Is that okay? Yeah, I think that you can see things there pretty good. All right, so let's come over here to our code where we'll keep, I don't think that we need J here. We're not going to need J, but we're going to be reading from the potentiometer, so we need pot val. That's the value that we read from the potentiometer. When we read from the potentiometer, we will read, we're applying to it 5 volts, and so depending on the position of the potentiometer, that center leg is going to be anywhere between 0 and 5 volts, and then that with an analog read will be represented by a number between 0 and 1023. If we read a 0, that's 0 volts. If we read a 1023, that's 5 volts, and anywhere in between. But pot val will be between 0 and 1023. All right, I got a delay time there. I'm going to speed this up a little bit. I'll make it 100. We do serial.begin 9600 just in case we need the serial monitor. Now we come down and make sure, let me get rid of all this stuff down here. All right, now what do I want to do? I want to read from the potentiometer. So I'm going to say pot, what did I forget to do? I hope you were yelling at me. We need to do our pin modes. Pin mode. And I forgot to even set up those variables for the pins. Okay, so I'm going to have an int, and I had I'll call it pot pin, because I'm reading from the potentiometer. Pot pin is equal to A0. And then I've got the LED, the red LED, so I'll say red pin. The red pin is equal to 7. And now I need to come down and do my pin modes, and so I need a pin mode for pot pin, and that is going to be pot pin is going to be an input. Happy little blue colors because we used all uppercase. And then I'm going to do a pin mode, and then I'm going to do red pin, and that is an output. And that is going to be good. That is going to be good. All right, I think I've got all that set up. So now what do I want to do? In my main loop, I want to read pot val. So pot val, I read it with what command? Analog read. What is the one parameter on analog read? It's where you read from, which would be pot pin. Okay, and then just for fun, I will do a serial.println, and I will do pot val. I'll print that in case we need to look at it. And also, I will put a little delay here just because it doesn't, so it won't go so fast that we can't see it. So I'll say delay. And then how long do I delay? 500. No, we use delay time. Okay. Now, okay, so I read the value. What do I want to do now? I'm going to say while pot val is greater than 1,000. So if I get greater than 1,000, I want to issue an error. So while pot val is greater than 1,000, that's the condition, then I'm going to open my clause, hit enter, and then, what you know I hate, it put this one in for me. So it ends that clause. So here is my clause. While pot val is greater than 1,000, what do I want to do? Digital write, and then what pin? Red pin, digital write red pin, and high. So I'm issuing a warning. I'm issuing a warning if the pot val is greater than 1,000. It's like a warning. All right. Now, what do I need to do in here? I've got to do another pot val read, because if I don't read pot val again inside the loop, it is just going to loop forever. It will never come out of that loop, because once it gets in it, pot val never changes. So now I need to read pot val in here is equal to analog read of pot pin. And then I ought to print it out again, serial.println pot val, and then I need to put a delay in here. You see, if I didn't put a delay in here, when it got in here, it'd run real fast because it wouldn't see this delay here. So if it's not in the loop, it's going to print delay, print delay. If it gets in the loop, it's going to print delay, print delay. All right, and now, if I'm not looping, if I'm not in that loop, that means that pot val is not greater than 1,000. What do I want to do? I want to digital write red pin, comma, low. So you see, if I'm inside the loop, that means pot val is greater than 1,000. I need to issue my warning light. If it is not in the loop, that means that pot val is less than 1,000, and so I don't want my warning light on. Does this make sense? Okay, guys, I really need you all to hold your breath. I need you to hold your breath so that this will compile correctly. Okay, so here we go. 1, 2, 3. Somebody did not hold their breath. Okay, and also this should have been red pin, but the real problem was somebody did not hold their breath. Whoever it was, whoever you were, I need you to hold your breath this time. Man, I did this more than once, huh? Red pin. All right, every last one of you, hold your breath this time. Boom! Okay, finally, everyone held their breath. All right, so let's open up the serial monitor and let's see how this looks. All right, so let me put this where you can see it. I believe this will work. Okay, so it's reading 16. Okay, it's reading 16. So let's see if it's changing. Yes, it is changing. And I need to show you also where you can see the circuit. Do I have a shot that will show the circuit? I am in need of a shot. Ah, this one will work. Okay, so here you can see the LED and you can see the serial monitor. All right, so you see it's at 0, the LED is off. I will come in and begin to turn it on, and you see how we're going up. LED is staying off. We are really hoping here. I got to be careful to not go over 1,000, right? You don't want to go over 1,000. I want to get real close to. I went over 1,000. What happened? Boom! The red LED came on, and it's staying on. But that's only half the battle, because the real trick is, if I bring it back, yeah, the LED is off. Boom! This works exactly like we wanted it. Are you beginning to see how the while loop is a little bit more natural when we're doing a circuit that has sensors and outputs? Now, the output might be something a lot more interesting, like a motor. And the input might be something a lot more interesting like a thermometer. But you could set up a while loop that says as long as the temperature is less than 70 degrees, leave the fan off. But while the temperature is greater than 70 degrees, turn the fan on. See, all of a sudden, the while loop is a little bit more, to me, a little bit more natural structure to use when we start using. Like right now, again, I'm trying to teach you to program, and I don't want us to get tied in a knot trying to make complicated circuits with a lot of sensors and more complicated actuators. We're using these simple things so that you can learn to program. And then after we learn to program, then we'll come back and we will start looking at some of the more interesting components in the eLego kit. Okay, guys, this is Paul McWhorter from TopTechBoy.com. Hopefully you will give us a thumbs up. Leave a comment down below, man. I love to hear back from you. Sometimes I wonder, does anybody actually watch the videos, or am I just sitting here talking to the wall? Okay, think about giving us a thumbs up, subscribe. If you subscribe, you need to ring the bell. You need to hit that bell, and then you will get notifications when the new videos come up. And think about sharing this with your friends. And also think about having some coffee. Okay, Paul McWhorter from TopTechBoy.com. I will talk to you guys